Hello everyone, welcome to today's lecture. So today we are going to start with chapter 5, Science 2, towards green energy. It is an important chapter. Okay, there are several questions which are asked from this chapter with a weightage of about 4 to 6 marks. Okay, first we will refer to go through. Can you recall questions? What is energy? It is the capacity of the body to do work, is called as energy. Now this is a part which you had studied last year. What are the different types of energy? The different types of energy include different types of mechanical energy is potential energy and kinetic energy. What are the different forms of energy? The different forms of energy is mechanical energy, sound energy, heat energy, light energy, chemical energy, electrical energy, etc. Okay. Now, energy and use of energy. In modern civilization, energy has become a primary need doing with food, clothes and shelter. We need energy in different forms for diverse types of works. The energy that we may need in the form of mechanical energy, sound energy, chemical energy, light energy or heat energy. How do we get these different forms of energy? From where do we get these different forms of energy? We get these different forms of energy from some other forms of energy. Basically, do you remember law of conservation of energy? Energy is neither created nor destroyed. It remains constant in the universe. It is getting transferred, converted from one form to another form. So if we have to produce some form of energy, we have to convert it from one form to another form. Make a table. Make a table based on forms of energy and corresponding devices. This table you had last year in chapter 2, work and energy. Do you remember? An electric heater converts electrical energy into heat energy. A thermocouple converts heat energy into electrical energy. A loudspeaker converts electrical energy into sound energy. A microphone converts sound energy into electrical energy. Okay, you may refer to chapter 2 of standard 9 or write these tables. These questions are not asked. Now, we know that energy can be converted from one form to another. Different sources of energy are used to the different forms of energy necessary for us. In previous standards, we have learned about energy, sources of energy and various concepts related to them. Here, we will learn about various sources that are now used for generation of electrical energy. So this chapter is basically about generation of electricity, different types of power stations which are working for generation of electricity. Okay, we will see what is done. Basically, which principle is used for generation of electricity. So the basic principle which is used for generation of electricity is electromagnetic induction. We studied about electromagnetic induction in paper 1. What is electromagnetic induction? That works on the principle Fleming's right hand rule. Okay, that means if you are moving a magnet in an electric field, otherwise if you are moving a wire in a magnetic field, then the current is generated in the wire. That is electromagnetic induction, that the electrons are forced to move. Now we may see, where do we use electrical energy in our day-to-day life? We use electrical energy in our daily life for the domestic appliances, for light, fan, computers, refrigerators, etc. How electrical energy is produced? It is produced in power stations. At power stations, an energy source, a turbine and a generator is there. There is an energy source, a turbine and a generator. The energy source gives energy to the turbine. The turbine starts moving. The turbine gets kinetic energy. That kinetic energy is made to move the generator, move the electrons or the magnetic field inside a generator. As the magnetic field moves, the current is generated in the generator. So generation of electrical energy, I'll read out that paragraph. Most of the electrical power plants are based on the principle of electromagnetic induction invented by Michael Faraday. According to this principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. The field around a conductor can be changed by two ways. Now I'll explain with the help of diagram which is given on page number 48. I have drawn the diagram here. This is the diagram showing electromagnetic induction, figure 5.1, that is electromagnetic induction. Here you may see there is a magnetic field. This is a magnet, okay, it is a magnetic field, and this is a coil which is connected. This is a voltmeter. This is a coil. Coil means the wire which is wound. Okay, now this magnetic field is rotated with the help of a source. This magnetic field is moving. When we studied about generator, then the coil was moving and the magnet was stationary. Here the magnet is moving and the coil is stationary. Okay, both are the same. The function is the same. Okay, what will happen? Either you have to move the magnetic field, keep the coil constant, or you have to move the coil and keep the magnetic field constant. But the basic thing is you have to move one or the other perpendicular to each other. So here there is a magnetic field which is rotating. When this is rotating, the electrons in this will start moving and the electricity is generated. What is electricity? It is movement of electrons. I repeat, I had told you this in the other chapter also in paper 1, that these electrons in this are just sitting idly. Okay, they are not doing anything, they are just vibrating. But if there is a magnet kept here and if the magnet is moved at a considerable speed, then those electrons get disturbed and they start moving. This is in simple language. You cannot write this in your test. Okay, so the electrons start moving, and that is what is called as electricity. Okay, so this is the diagram of electromagnetic induction. Now how to move this magnetic field? Okay, this magnetic field is connected to a turbine. Such turbines you might have seen. Okay, this is figure 5.2, which is a steam turbine. In this there is a shaft. This shaft is connected to here. Okay, this shaft is connected here. Okay, and there are blades for this. There is a nozzle. From this nozzle, the steam or whatever energy it is, from the steam we get heat energy, and it is at a particular force which is made to fall on these blades. When it is made to fall on this blade, this will start moving. There are several blades, so each and every blade, they will start moving. When this moves, this shaft is connected to this, this will move. When this moves, the magnet will move. When the magnet will move, the electrons will move. Okay, so basically what is the thing? There is a turbine. The turbine has to be moved from some source of energy. That is this proper energy source. Okay, so there is a proper energy source. That proper energy source is used to turn the turbine. The turbine turns the generator. Okay, this is connected to the generator. The turbine is connected to the generator and the generator will move. Now you may see this is a generator. This also could be a generator. So here this is the magnet, south north they have shown, and this is the coil. This is the coil. This will move in this direction, or left to right or right to left, or clockwise, anti-clockwise, that depends. Okay, it is moving like this. Which one? This blue part. The blue part will move like this. The coil will remain as it is, and inside the coil the electron will get disturbed and they will start moving. That is electromagnetic induction. So there is a proper energy source which is turning the turbine. The turbine is used to turn the generator and the generator will generate electricity. Okay, so this has been given on page number 48. You may read it. This question is asked, this diagram is given and the question is asked. Even this diagram is given and the question is asked. The question is, what is the principle on which they work? What is the principle? It is electromagnetic induction. And there is a paragraph on page number 47. Last paragraph. If a conductor is stationary and the magnet is rotating, the field around the conductor changes, or if a magnet is stationary but the conductor is moving, then also the field around the conductor changes. Thus, in both the cases, a potential difference is created across a conductor. The electrical power generating machine based on this principle is called as electric generator. So first, what you have to understand, either you have to move the magnetic field or you have to move the coil. In both cases, a potential difference is generated in the wire, that means in the coil. Okay, now we will see the first type of power generation in our syllabus. Now we will see the working of first power station according to our syllabus, that is thermal based power station. Okay, thermal power station, you might have heard about it. How it generally works. I have shown you the diagram here, diagram 5.7, figure 5.7 on page number 49. Okay, so I will tell you the basic working, the outline of working of a thermal power station. So this is a boiler. Okay, first I will start from there. Boiler. Inside the boiler there is a coil. The S part which I have shown, that is a coil. Inside the coil there is water. Okay, inside the coil there is water. And where is the fuel? Fuel is coal. Okay, fuel is coal. It is inside this particular setup. Okay, the boiler and the part where the coal is burnt, they are one set. It is the one setup. So the fuel is burnt. When the fuel is, what is the fuel? It is basically coal. So when the coal is burnt, the water in the coil will get heated. The water will get heated and it will get converted into steam. When it gets converted into steam, it will rise above. It will go through the coil. It will go through the coil in the upward direction. Okay, it is made to fall onto the turbine. Okay, the turbine I had shown you in the other diagram. Okay, there was a nozzle and from the nozzle the steam falls onto the blades of the turbine. Okay, it falls onto the blades of the turbine and the turbine will start moving. When the turbine starts moving, the setup inside the generator, it starts moving. Either the coil moves or the magnet moves. Okay, as it is moving, the current is generated, which is shown as positive and negative. Okay, so the current is generated by the generator. What happens to the steam? The steam which is falling onto the turbine, it is falling onto the condenser. What does the condenser do? The condenser condenses the steam into water. The condenser condenses the steam into water. The water which is formed, okay, it is pumped back to the coil. Now there is a cooling tower. There are two towers. One is a stack and other is the cooling tower. What is the purpose of cooling tower? It is to help in condensation of steam to water. From the cooling tower, the cold water comes towards the condenser. It does not fall into the condenser. Again, these are also pipelines like this. Understood? It is a pipeline. The water is flowing through the pipes. It is not falling into the condenser. When the cold water is flowing through the pipes, due to that coldness, the steam will get converted into water. Due to that low temperature, the steam inside the condenser will get converted into water. Okay, and that water is pumped back to the coil. what happens to this cold water? That cold water will take some amount of heat energy. You studied in heat, okay? There is give and take of heat, okay? Heat energy lost by the hot object is equal to heat energy gained by the cold object. This will give heat and take heat, okay, and this will get warm and it is pumped back into the cooling tower. So this water is circulating like this and this water is circulating like this, okay. So I repeat, I will start from the boiler. Inside the boiler the fuel is burnt. During the burning of the fuel, several gases are produced. Those gases are given out through the stack, okay. The basic gases, the poisonous gases. Combustion, what do you mean by combustion? It is burning. Combustion gases to the stack. So what is stack? It is a chimney like structure which gives out the gases into the atmosphere. The fuel is burnt. Due to that heat energy, the water inside the coil boils. It gets converted into steam. The steam rises up. It falls on the turbine. The turbine moves the generator and the generator generates electricity. The steam from the turbine falls into the condenser. In the condenser, it gets converted into water and it is pumped back into the boiler. There is a cooling tower which supplies cold water to the condenser for condensation of steam, and that water is recycled. It is recycled as warm water into the cooling tower. This is the working, the setup of a thermal power station. Now we will see how the electricity is generated. There are two charts, figure 5.5 and 5.6. These charts are important. Either they will tell you to ask you to draw the chart or they will give you to fill in the boxes. Okay, so you have to learn all the charts in this chapter. There are several charts. It is very, very important. So in a thermal power station, there is fuel coal in the boiler for conversion of water to steam. It is this fuel coal is burnt for conversion of water to steam. That steam, it is made to move the turbine, that is steam turbine. That steam turbine moves the generator and the generator generates electrical energy. Now there is a system for converting steam back to water which is connected to steam turbine and the boiler. Okay, there is a system, that is condenser. Okay, so this is the flow chart for generation of electricity. Now next is the flow chart of energy conversion. So the chemical energy in coal is converted to thermal energy which is used to boil, which is used to turn the turbine, that is kinetic energy of the steam, which is converted into kinetic energy of the turbine because the turbine moves, which is converted into electrical energy. So I told you earlier, energy can neither be created nor be destroyed. It has to be converted from one form to another. So here the chemical energy in the coal is first converted into thermal energy by burning it. Thermal energy is converted into kinetic energy of steam, okay, and it is converted, it is passed on to the turbine, then the turbine moves, that means the kinetic energy in turbine which is converted into electrical energy, okay. So these are the two flow charts. Now on page number 49, let's think question. Why the energy in the coal is called as chemical energy? Because coal is a chemical substance. The energy stored in the coal, that chemical energy, is released in the form of heat. Okay, so again the chemical energy of coal is converted into heat energy. The chemical energy of coal is converted into heat energy, and that energy is used for conversion of water to steam. Okay. Why steam is used to rotate the turbine? Now why steam is used? First, it is cheap and easy to handle. Cheap and easy to handle. Second, it can be recycled. There are two uses, cheap and easy to handle. it can be redirected, recirculated for usage. Okay, so you may read that paragraph. Now we may move on to page number 50, the problems of thermal power stations. Now there are some negative points for thermal power stations. We will see the first one. This is an important 3-mark question. Air pollution due to burning of coal. Burning of coal results in emission of gases like carbon dioxide, sulfur dioxide and nitrogen oxide, which are harmful to the health. Along with emission of gases due to burning of coal, soot particles are also released into the environment. Soot particles means carbon particles, black colored particles which are given out into the atmosphere. This may cause serious health problems related to respiratory system. The reserves of fuel used in this method, that is coal, are limited. Therefore, in future, there will be limitations on the availability of coal. So, the basic problem is air pollution, and the second basic problem is limitation in fuel, that is coal. It is a fossil fuel. Okay, fossil fuels is decreasing in number nowadays. Okay, in decreasing in quantity. So, we have to take care. We have to use only enough amount of coal. So, these are the problems with thermal power stations. Now, do you know point which has been given in the box? Some major thermal power plants in India and their capacity. From that, Chandrapur, you have to learn, it is in Maharashtra. 3340 megawatts of electricity is produced by that thermal power station. Why it is important? Just because as it is in Maharashtra, that's all. Okay, there could be a question asked, nothing else. So we have finished with the first part of the chapter today. You may read this part. I am not going to give you any homework today. First, read it very, very thoroughly. Okay, thank you.